Tutorial, we're going to go over ltrace. So, if you've used ops in the past, we have a few sort of set of debugging utilities. We have, an strace equivalent. We have a ftrace as in Frank equivalent. Today we're going to be introducing ltrace, as this PR suggests. Ltrace is to help trace out dynamic library calls. So, I kind of ran into this and requested my team make this because I was actually debugging some application for an end user, and I was using ltrace on Linux to figure out what host it was actually this application was talking to. And then I kind of remembered, oh, we don't really have the equivalent in nanos, and so that's why I asked for it. Anyways, let's get into the details and see what this is all about. All right, so we have this program. It's called main.c. It's pretty basic, right? We have a char star here. We're going to allocate some memory, then we're going to free it, and then we're going to just, printf, right? Pretty basic program. When we run it, obviously it just prints test because we don't see the memory allocation. Using this -- trace with ops, we can run it, and we'll get syscall output. This is the same sort of output that you would see if you did, an strace, for instance. Right? So same sort of output there. But there's this other thing called ltrace. And so you can see ltrace puts out different information. So if you're following along at home, this is essentially the difference between man2 and man3. All right, so let's get to the meat of it. If we have this program, how do we do our ltrace using this branch, by the way? Well, first off, you need to realize what kind of program it actually is. Most programs that you're going to find on modern day systems like Ubuntu, for instance, they're going to be compiled with Pi, which is position independent executable. And that's one reason is because ASLR, which kind of randomizes various locations of the programs to make attackers, guess at where memory lies. So that's one thing that you're going to run into. So when we're compiling this program, you need to do a -nopi to get your magic, right? And then to turn this on, we're just gonna put in our manifest pass-through, this ltrace. We might extend this in the future. I've already got some ideas on what I want to extend it with. But let's do an ops run, config, and then main. All right, so now you can kind of see our calls to malloc, our calls to free, and our calls to puts are all showing up, which is exactly what we want. Just to show you the difference between not having nopi, we can show that it's not there. And again, that's just because this Pi executable is here versus when we run file, it's LSB. All right, so that's the new thing that we got to show to you, and we'll catch you next time. Bye.